Hello and welcome to our poster.
In everyday tracking, objects often temporarily disappear from observer's view to reappear later. For instance, while driving on a busy road, some cars may slip into your blind spots. In order to drive safely, you need to maintain an approximate location of the hidden cars in your memory because you cannot track them visually at the moment. Consequently, everyday tracking seems to require both working memory and attention. Multiple object tracking is a popular experimental method for testing human ability to track objects. Usually, scientists emphasize the role of attention in this task. Here we introduce a variant of the task where people need to rely on both attentional and memory tracking. Our experiments generally follow the standard multiple object tracking design. Participants are shown 8 objects and some of them are marked as targets to be tracked. After a few seconds, all objects turn black and start to move. And after 8 seconds, objects stop and participants mark the previously highlighted targets. In our experiments, we limited the object's movement to a circular arena to avoid corners. Actually, we also made the objects bounce off the central invisible boundary to push objects closer to the potentially hidden areas. We limited the participants' view with a circular aperture. The aperture ensured that objects partly or completely disappear when approaching the outer edge of the annulus. In the first experiment, we explored the impact of cover on the tracking performance. We introduced 4 levels of cover, which meant people could see from 100% to 53% of the area where objects moved. We found the amount of covered area and the corresponding probability an object will not be visible substantially affects the tracking performance. Maybe with more available resources, people will be better in memory tracking. In experiment 2, we manipulated both the tracking workload, ranging from 2 to 4 targets, and the amount of cover. Having more available resources helped, however, this benefit was small relative to the changes caused by the amount of cover. Remembering the identity of the tracked objects usually makes the task more difficult. We can speculate whether if people devote more memory resources when tracking the identity, it may help them with tracking behind cover. In experiment 3, people tracked 3 objects under 3 different cover conditions and either in multiple object tracking or multiple identity tracking versions in a randomized order. Identity tracking was more difficult, which is consistent with previous findings, but similarly to the previous experiment, the effect was small relative to the effect of cover. Occlusion is usually used in tracking to study the role of motion extrapolation. This occlusion is usually limited to only a small part of the view. However, in everyday situations, the objects are not guaranteed to stay within our view, and we must also rely on memory. To summarize, here we show that people can track objects relying not only on their attention but also their memory. This memory tracking is difficult and more demanding than other common manipulations in tracking. On a theoretical level, serial accounts of tracking assume we use memory in our tracking. Our observations show that although people can track objects only with their memory, it is not effortless and it affects the task performance.
Thank you for your attention.